and good day, everyone. My name is Adam Gauci, and I am working with the EcoStruxure Power team, specifically in cybersecurity. And I'm going to speak a little bit today about cybersecurity for electrical distribution within EcoStruxure Power. So one thing that's a fact of life today that is becoming more and more of a trend that we see is that things are becoming more and more connected. The electrical distribution panels, from the breakers right up to the control software, is connected. And not only that, we're connecting more and more to the cloud to be able to take advantage of new features and functionalities that we can provide within electrical distribution. But this is something that we're starting to see more and more as a part of an IoT program. And one thing that's very important is that that our customers and your customers are engaged with cybersecurity. And one very interesting account that we see, or one very interesting quote that we see coming from Gartner, is saying that IoT cybersecurity will account for 20% of a company's information security program by 2020. So this means that most companies that are out there today will have to account for 20% of their budget related directly to IoT cybersecurity. So all of the connected devices that they can have, and that can be anything from a thermostat to a connected circuit breaker to a connected light bulb that they could have in their system that they will be accounting for. And what's very interesting about this is back in 2015, less than 1% of a company's cybersecurity budget was related to IoT. So as we see now more and more, our customers and your customers will be required to consider the cybersecurity of their IoT systems. So specifically for electrical power, for electrical distribution, what are the key impacts for cybersecurity? We talk about risk. And risk is really the likelihood of an attack, a cyber attack that could happen on your infrastructure, times the impact of that type of attack. And that's what we call cybersecurity risk. So when we're building our connected systems, we have to take into account the cybersecurity risk that we could have. And what we're starting to see more and more is the likelihood of cyber attacks are rising. We're starting to see more and more expertise that's out there today in being able to do cyber attacks against what would be embedded types of systems, and they're becoming more and more prevalent as we go. And of course, there's an impact to that as well. In an electrical distribution, there can be a cost to an outage, to a power outage. So some things that are very interesting that we found, for example, if there's a power outage in a 200-room hospital, we found that it can be up to $1 million euros for every 8-hour event that's out there. And on the other side, when we start going into a heavy industry like oil and gas, one customer I had worked with had told me that for them, if they have a power outage that causes loss of production, that for them could be up to $30 million a day in terms of lost revenue. But cybersecurity risk aside, that's something we can manage. We need to be able to connect. There's huge benefits that come from connecting your electrical distribution systems. And these are the potential benefits that you can find from the Internet of Things, from IoT. So we look at different types of functionalities to be able to allow us to be able to detect the condition of our devices, to be able to do condition-based maintenance. We're able to make our systems safer by being able to detect hotspots in our electrical equipment, to be able to prevent fires and protect our people faster by connecting them, by using these types of connected sensors. So for us, there really is an added benefit of connecting that outweighs the potential risk of cyber compromise. And not only that, when we think about cybersecurity, a lot of times people think, well, I can just close the door and not connect anything, and that's fine. But a lot of times also we need to be able to protect against not only outside attacks but inside attacks. And these are not only what we would call malicious inside attacks. They're actually people who inadvertently can cause problems on a system. For example, bringing in an infected USB device into a closed system could potentially cause a cyber incident in the system by releasing malware, for example. So one of the ways that we are able to talk about cybersecurity and to be able to talk about what is required to protect us for cybersecurity is through standards. And I wanted to introduce you to a very important standard in the IoT or OT, the operational technology world, called IEC 62443. And this is a very important standard because it allows us to discuss cybersecurity based on the different actors that we have in a system, and something that is specifically designed for an OT system. This meaning that it's a system where we need a very high level of uptime, of availability in the system. So it's really meant for real-time types of systems. And it's split up into kind of three main areas. One area that's related to policies and procedures. One part that's related to cybersecurity systems. So how do I manage all of these different devices from a system perspective to make sure that I'm not missing anything? And then from a component or device or connected device point of view. So let me go a little bit deeper into what this means. Within IEC 62443, we have specific requirements for different actors in the system that we have today. So in this type of situation, we take into account three main types of actors. One can be a product supplier, for example, such as Schneider Electric. When we are developing our products, we follow a certain procedure. So the standard talks about processes and procedures. So the process and procedure for developing a product is called the secure development lifecycle. It means that we take into account all of the certain types of requirements for development. We take into account training for our developers. We do risk assessments and threat models. And then we do specialized penetration testing afterwards as well within this type of standard. Apart from that, our products contain very specific cybersecurity functional requirements that need to be in certain products. And then these products are integrated into a system. So a system or a solution is made up of many different types of products put together into a secure network architecture that is developed using techniques like zoning conduit analysis to develop that system, that secure architecture. These systems also require a certain level of cybersecurity as well. So there are specific functional requirements at a system level. So for example, if I have a product that is connecting to an Active Directory, I need to have an Active Directory server somewhere in my system for those products to connect to. So that would be at a system level. If I'm doing anti-malware, I'm including an antivirus like McAfee. I need to be able to have an update system to be able to update on a regular basis those patterns on the device. So these are things that you'll find at a system level. So typically, there is a system integrator who is developing the system, designing the system, and they do this type of integration using a part of the standard called 62443-2-4, which talks about secure system design, testing, commissioning, and maintenance of that system. And last but not least, you have the person who is operating the system. and they also have specific requirements for their organization and processes that they have to follow to maintain the level of security that they have in their system. So this standard is very interesting because it's very clear on which requirements are for each different type of actor that we have in the system. Whereas we see a lot of other standards out there that are really oriented towards the asset owner and operator. For example, you have regulations or standards like NERC-CIP, for example, in North America, that is really oriented at this level. So this one's very clear, and they're all nicely tied together. So they reference each other throughout the different parts of the standard. Another very interesting part of the standard is we start to allow the concept of security levels. So as the customer's risk increases, they have the ability to choose a security level or a protection level that would be appropriate for their system. So we talked about risk a little bit earlier. If I give the example of a hospital, for example, in a hospital, I have different zones in my hospital. Maybe I have an office zone where the impact of an outage might be I lose some of my lighting, for example, if I have an electrical outage. If I move into an operating theater, for me the impact would be if I have an outage in that operating theater, that potentially somebody could die. If there's an outage during an operation, for example. So what I would do is I would have the capability to be able to choose different security levels for these types of scenarios. So for example, in the office, I might choose an SL1 level, which is protecting against maybe some basic risks, basic or more risks. And we're moving to the operating theater, I might require to have an SL3 security level. So this protects me against more sophisticated types of attacks or attackers who may have more expertise in cybersecurity. So as we go up, we start to see that some of the actors who are acting at these different levels might be going from basically an employee who might do something accidentally to a nation state who has a lot of resources to be able to carry out different types of attacks. So depending on your customer's assessment, they can choose the security level they would need. And then behind that, there are more cybersecurity requirements, more cybersecurity measures that would need to be put in place to protect their system. And of course, the complexity goes up as you increase the security level as well. Within the standard as well, we have this concept of foundational requirements. So all of the requirements that we see at a product level, at a system level, they're all grouped into these 7 different types of categories. The first category is really around identification and authentication, how I identify myself and connect to a device. The second one is around usage control, so the authorization. What can I do when I connect to this type of system? The next one is integrity. So this means, can I trust the data that I'm getting from these devices? Can I trust the other components in my system? That's integrity. Data confidentiality, keeping the data private. So in some cases, we work with a lot of metering data. Some of this metering data in certain situations, like in data centers, for example, can really be competitive information for your customers. So sometimes data confidentiality is a requirement as well. Restricted data flow. So this talks about, for example, you can imagine having the right types of firewalls, the right types of zones and segmentation in the network that you're working on. Timely response to events. So this means that all of your data is logged, correctly logged. So you have the ability to detect if something unusual is happening, and you can respond to those different types of events. So being able to maintain a security log and to be able to respond. And then after the fact, being able to do any sort of forensic analysis that you would need if something happens. And the last but not least, FR7 is really based around availability. So keeping the system running at all times, having a high level of availability of your electrical distribution system. So with that, we have the concept of being able to define for a device or for a system what we call a security level vector. So we can actually set an SL level for each foundational requirement. And in this case, you can build something like this. So if we want to kind of dive in one level lower than this, this is just an example of FR1. So what we would see as the requirements for identification and authentication control. And as you see, as we move up on the SL level, we require more and more specific requirements in the system. So for example, all of the green requirements here would be required at SL1. As we move to SL2, we would now include the green and the blue requirements. So as the system becomes, as we increase our security level for the system, we also increase the amount of requirements that we would need in the system. Now I'm going to go a little bit into, so that was a little bit in terms of 62443. That's our, which is our cybersecurity framework standard that we have at Schneider Electric. Now I'm going to talk a little bit about how this security applies directly to our Schneider Electric EcoStruxure Power offers. Today in EcoStruxure Power, we are working diligently to make sure our offers are cyber secure. And today I'm going to talk a little bit about our offers at the edge control layer, so our SCADA offerings, our power monitoring offerings, and also at the cloud layer. I'll touch a little bit about where cybersecurity is at the cloud layer. First off, today we do have one of the very first secure edge control layer softwares. Both of our power monitoring expert and our power SCADA operations softwares have been certified to the SL1 level today, and we hope to continue this trend and as we develop our software to increase this SL level as time goes on. But today we've had these two offers certified by TÜV Rheinland for IEC 62443-4 at security level 1, and they're one of the first ones for electrical distribution. So what does this mean within our power SCADA operations software? Not only is it certified, but it also has some very unique features that also add to the cybersecurity. One is our two-factor authentication. This means that when a user needs to be able to log into this type of SCADA, they have the ability to not only just use a password, but they can also use something they have as well. In this case, it's a special key that they can use to connect to the SCADA client. So they need a password and a special key. It's been tested and is working with some of the latest network firewalls in conjunction with what we call deep packet inspection. So being able to actually view what type of communications is going on to the network to be able to detect if something unusual is happening. And we also have this solution working with a whitelisting solution. So this means that it's one step above an antivirus, for example. A whitelisting solution means that the PC is protected and only will run validated software. So it's kind of the opposite of an antivirus, where antivirus looks for blacklisted software. A PC running a whitelisting solution will only run validated software. So in this case, it only runs the bare minimum for the operating system for Windows and our PSO software, not allowing any malware to run. With our PME offer, we have a very similar type of solution with the certification. And we've also included in that the whitelisting as well. This tool also runs through a web interface, so a lot of time there's even no specialized software that's required. You can just access the client of this software on directly from a web browser, and of course being able to log in to the server through the web browser using role-based access control. And of course, it wouldn't be complete unless I mentioned what we are doing for cybersecurity at the Schneider Electric cloud layer. And Schneider Electric's cloud is managed by our IT department within Schneider, so Schneider Electric Digital. We have a very strict cybersecurity policy at our cloud level. We make sure that all of our development assets for our cloud applications are developed in a secure environment. So all of our assets that we develop on are secure. We follow a very strict cybersecurity development process, a secure development lifecycle for these cloud applications. And then we also have a very secure solution design. So we have a very secure architecture that these types of applications need to follow. We have a secure operations management lifecycle as well. So we do what's called SecOps, and we have a security operations center that is monitoring our cloud applications on a regular basis. We are aligned with some of the latest data privacy regulations. We have a data privacy officer within Schneider Electric who ensures that we're following the latest regulations for data privacy, like the GDPR in Europe, for example. And in the cloud, we're working with partners who are also certified for cybersecurity. So in this case, we're working very heavily with Microsoft Azure as one of our platforms, and they are secured today as well. On top of that, we offer cybersecurity services for being able to help deploy specific cybersecurity solutions. So when we talk about cybersecurity, a lot of times we also have to think at the system level. In that system, we need very specific solutions to be a part of our system. These solutions, a lot of times, we can be provided by Schneider Electric. These are off-the-shelf cybersecurity solutions coming from third parties that we have adapted to be able to run in a OT or IoT type of environment. So when I start off, and I'm one of your customers who needs to be SL1 compliant, these would be the different types of solutions that I would need. As I move to being SL2, for example, that increases. Now I have a requirement to have even more functionality in my system. So what we can do at Schneider Electric is we have this type of menu where we can provide different types of solutions at these levels with common off-the-shelf components. We also have the capability to help determine where your cyber risk may be existing. So, for example, if a customer already has an existing system that's out there today, maybe that they want to retrofit, or if they're trying to design a new system, we have the ability to do a cybersecurity vulnerability or risk assessment for you and your customers. This allows us to be able to go in and compare their compliance to a specific standard, such as 62443. We can find where the majority of their risks are existing, and we can give some recommendations on what they can do to reduce the risk in their system. And of course, they can always just choose the most critical risks that they see, and they can implement a mitigation towards that. So, for example, one thing that we regularly see a lot of times in OT environments is people don't really do their updates. So, for example, we see a lot of SCADA systems that could be running Windows XP still today. Windows XP is not secure at all. It hasn't had any security updates in a really long time. So one of the things that we may recommend is that they upgrade to a newer version of Windows 10 and they implement a patch management program. And these are things which we can help to design and implement at the customer. Afterwards, we have the ability to, once the customer has improved their level of security or they have a very good security baseline, we can help them maintain that security baseline. So security is not something that's a one-shot deal. It's something that continuously needs to be maintained. So within our services, we can help to maintain that security level through a service level agreement. And last but not least, we also offer cybersecurity training, from basic awareness training of how to act in a secure way within the environment, right up to expert cybersecurity training to be able to manage the cybersecurity in an OT or IoT context. And we do all of this today working with a lot of our cybersecurity partners. So today we work with a lot of off-the-shelf components that we've adapted with our expertise and are able to apply in these OT systems. So thank you very much for this opportunity to introduce you to cybersecurity. I hope it was a helpful introduction for you. If you would like more detailed information or go into details on any of these topics, Schneider Electric has our Cybersecurity Virtual Academy, which you're welcome to connect to, and it has all sorts of really interesting information about cybersecurity. And you can access this link via the My Schneider Partner Portal. Again, thank you very much, and I wish you a great rest of your day.